Welcome back. Big data processing has a long history of collecting humongous volumes of data and process it in smaller and regular batches using distributed computing frameworks such as Apache Spark. However, the business started demanding more and more frequent batches. In many cases, these expectations started reaching to produce results in a few minutes and even a few seconds. However, producing some results every minute or second is not an easy goal. Let's assume you are a stockbroking house. You have trading terminals across the country. Your customers and your employees are buying and selling stocks from those terminals for the entire day. These trades are continuously producing transaction records with the following information. Your trade starts at 9:15 a.m. and it ends at 3:30 p.m. You are a big company and your offices are generating millions of transactions in every 15 minutes. However, you have an excellent infrastructure design in place and you manage to bring these millions of records to your data lake in less than 15 minutes. What does it mean? It means each transaction takes less than 15 minutes to travel from the terminal to your data lake. Now the business is asking you to produce the following report, which refreshes every 15 minutes. The x-axis is the time and the y-axis is the amount in thousands. The blue line is the cumulative buy. So it started with 0 at 9:15, but the total buy reached a little over 5 million by 10:15. Similarly, the orange line is for the sell and the gray line shows the net value that goes for settlement. By the end of the trading session, you have roughly more than 2.5 million in settlements. Now you are expected to create a Spark application that simply computes the total sell and buy every 15 minutes. How are you going to do it? Think about it. Let me give you some hint. You already have a data ingestion pipeline, which is expected to create a data file every 15 minutes in a distributed storage. So let's assume you have the following directory. Your data ingestion job is supposed to create one data file at 9:30. This file should contain all the transactions performed between 9:15 and 9:30. You will get another file at 9:45. This file should contain all the records generated between 9:30 and 9:45. And this file creation must go on until 3:30 p.m. You keep getting one new file every 15 minutes. And this is the ideal case expectation, which is almost impossible to achieve. I'll come back to the point of why creating a file every 15 minutes is not practically possible. But let's assume that we achieved it. You are getting a file every 15 minutes. Now you are supposed to compute these 3 points every 15 minutes. How will you do it? Think about it. First thing first. You will create a Spark application to do this and schedule it to start every 15 minutes, right? And the application is going to compute these 3 numbers. Computing these 3 numbers can be done in 2 ways. Read and process all, and read and process incrementally. The first option is to read all the data in this directory, compute these 3 sums. So at 9:15, you will read only one file and correctly compute the sum, right? When your job again starts at 9:30, you will have 2 files. So you'll read both the files and compute the correct results for 9:30. And this goes on every 15 minutes. Make sense? I know you already started identifying a bunch of gochas in this approach. What about the performance? Every 15 minutes, I am processing more and more data. After 3 hours, I'll be reading 12 files, right? My jobs are not going to finish in 15 minutes. This approach might not work. Nothing to worry. We have a second approach. In this approach, I'll be reading only one file. So I'll start at 9:30, read the first file, compute the sums and keep it somewhere. I'll again begin at 9:45, read the second file, calculate the sum and add it to the previous sum and keep it the new value. And this goes on every 15 minutes, right? So in this approach, I'm only processing the sum for the most recent file. Then I'm adding it to the sum of the earlier files to get the cumulative value, right? This all looks perfect. However, you may have to do some housekeeping activities. I mean, let's assume you started at 9:30 and finished the first batch. You again started at 9:45, but now you have some questions to answer. How many files do I have in the given directory? Which one I processed last time? And which one is new? What if the new file is not yet written? Should I wait or terminate for the another 15 minutes? What if the current batch fails for some reason? How would I know where to start again? What if the previous batch is still running? Should I start or wait until the last batch finishes? These are some failure cases that you must handle in a production grade application. Some of these problems are not unique for smaller batches. They already existed in longer batches as well. For example, even if you are running a batch job once a day, you still need to know which file you processed yesterday and which one you want to process in the today's batch. But such problems were a little easier to handle for daily or hourly batches. However, you should also realize that all these failure cases are common problems that every application should handle. Don't we have these facilities in Spark framework itself? Why Spark cannot give a solution to such problems? Well, Spark gives an answer to all these problems. And that's what this course will teach you. However, I want to highlight another problem specific to smaller batches. And we ignored it in the earlier discussion. I made an assumption earlier that your data collection job is going to create a file every 15 minutes, right? So the 9:30 file is created at 9:30. And this file is assumed to have all the transactions that are created between 9:15 to 9:30, right? However, this is almost impossible. Why? Because the transaction is created at the trading terminal. We must transport the transaction from the terminal to the data lake, right? We made one assumption that we have excellent infrastructure and each transaction reaches to the data lake in less than 15 minutes. So, a transaction created at 9:29 should reach to the data lake by 9:44. However, the data collection job is creating the first data file at 9:30. So the record generated at 9:29 will not make a place in the first file. It can only get into the second file. What does it mean? Simple. The sums that we calculate using the first file are incorrect. They do not have all the records which are generated between 9:15 to 9:30. Some records are arriving late. So you start considering these late record scenario. You will realize that each file will have some records for the current interval and some other records from the previous interval. So it is almost impossible to create the correct file for 15 minutes of duration. How do you handle these late arriving records? The point is straight. Stream processing is not a subset of the batch processing problem. It is a bigger problem than batch processing. You still have the batch processing problems which you must solve. And the stream processing poses a bunch of new difficulties for you to handle. In fact, a batch processing is a subset of the stream processing. And that's how Spark implements stream processing as a superset of batch processing. I mean, Spark extends the batch processing data frame APIs to solve the stream processing problems. We will start learning those techniques from the next video. However, let me summarize the main takeaway of this video. Stream processing is a superset of batch processing technique. Many of the batch processing problems are also addressed by the stream processing solutions. For example, a stream processing job can take care of the scheduling requirements of your batch jobs. It can handle job failures and restart again from the same point where it failed. Streaming jobs can maintain intermediate results and combine the results of the previous batches to the current batch. They can also track if the previous batch is still running and wait for the completion before a new batch starts. Other than these, stream processing also offers you a bunch of facilities to solve unique streaming problems. I already talked about the late arrival of the records. We'll learn some other problems and their solutions as we progress with the course. And finally, Spark stream processing is an extension of the Spark data frame APIs. So the learning curve is a lot simpler for those who already learned Spark data frame. Great. That's all for this video. See you again. Keep learning and keep growing.